This video aims to provide a fundamental background of the concept of pressure drop and how it relates to the orbit rotary steerable system. When talking about pressure drop, we are focusing on the bias unit. This is the sub with the pads attached to it, located directly above the bit. The bias unit's job is to push the bit in a specific direction. It accomplishes this by diverting a small percentage of the mud system to a specific pad. In essence, converting the hydraulic pressure of the mud into a mechanical force used to push against the wellbore. For instance, if the DD wants to steer to the left, the control shaft will point this half moon to the right. This, in essence, is diverting flow into one of these three silver tubes, each tube connected to an individual pad. This results in the pads actuating every time they are positioned on the right side of the wellbore. This pressure drop needs to fall within a specific range, and when calculating pressure drop, there are three variables to consider: flow, mud weight, and TFA. You'll notice here the flow is directly related to pressure drop, as in the higher you flow, the higher your pressure drop will be. Also directly related is the mud weight. So as your mud weight increases, so will the pressure drop across the bias unit. And then lastly, the TFA is inversely related. So the smaller the TFA, or the smaller your nozzles, the higher your pressure drop will be. So why do we care about pressure drop? Each orbit has an optimal range the pressure drop must fall within. The pressure drop is our way of measuring how hard the pads will push off of the formation. So in essence, the higher the pressure drop, the better our steering response will be. But there is a maximum pressure drop the tool can handle before wash or erosion-based damages do occur. On the other hand, if our pressure drop is too low, we are no longer at risk of damaging the tool, but we will lack the expected dogleg capabilities. So we use the software called PD Squared as a tool that gives us the ability to optimize the hydraulics for each run by finding the right balance between steering effectiveness and reliability. So to summarize this pressure drop video, remember there are three main factors: flow, mud weight, and TFA. Remember, if your parameters change during the run, you need to reevaluate what your corresponding pressure drop will be and adjust accordingly to maintain the optimal balance between steering and reliability.